Hello everyone. Hello everyone. You are welcome back again to the academia series. It's been a long time I posted a video. I've been a little busy. Forgive me. Now I know your BEC is around the corner, and I know you are preparing seriously to write the exam and come out with flying colors. I'm also going to present to you something on the balancing of chemical equation. I know it is a headache to most of you. That has been a popular request. So I'm putting up this video to help you with the balancing of chemical equations. Please do not forget to subscribe to my channel. Call your friends. Recommend the channel to your friends as well to watch and learn some of the things that I've posted there. It is because of you that I did it. Please, when you watch and I get feedback and you subscribe as well, I become very happy to do more. Now let us continue. And at the end of today's lesson, I expect learners to be able to balance simple chemical equations, know all the tricks involved, and balance simple chemical equations. Now, in the last presentation that I did, I remember I touched on word equations, where you are to use the name of the compounds or the elements to form an equation. For example, sodium and chlorine to form sodium chloride. And then I attach the chemical equations as well, so that sodium is Na, chlorine is Cl2 to form that. Remember, sodium exists as an atom, but chlorine exists as a molecule, specifically gas. So do not write sodium and Cl. That one is not correct. Write the state in which they exist. So sodium is an atom, so Na. Chlorine is a gas, Cl2 to form sodium chloride. When I say hydrogen and oxygen to form water, that's the word equation. But then let's look at the chemical. I have H2, that's how hydrogen exists. I have O2, that's how oxygen exists to form water. Please be mindful, these equations are not balanced. I have aluminium, which is a metal, and I have sulfur, which is a molecule. So even they react, this is what I get. So in the word equation, aluminium and sulfur give me aluminium sulfide. Calcium and hydroxide give me calcium hydroxide. That is the chemical equation here. Ammonium, ammonia and chlorine gives me ammonium chloride. All right, please correct this. This is ammonia, not ammonium. Now let's look at a chemical equation. Remember that a chemical equation has two parts. You have what is on the left-hand side and what is on the right-hand side. On the left-hand side, we call them reactants. They are reacting, so reactants. And then on the right-hand side are the products. So we use the arrow always as our barrier. So left-hand side, right-hand side. So CH4 and oxygen are reacting. They are the reactants. And what are they going to form? They will form carbon dioxide and water. So do not forget that. Now, in balancing chemical equation, for example, if you have been given sodium and chlorine to form sodium chloride, I want you to know that we only balance equation by putting numbers in front of the reacting or the species or the product, so that we can see that sodium is 1 here. On the other side, sodium is 1. So in terms of sodium is balanced. Chlorine is 2 here, by chlorine here is 1, making the whole equation unbalanced. I cannot say I'm going to balance chlorine by putting 2 here, 2 on this side, so that it's balanced. No. If you do that, you will form a different compound, which is no longer sodium chloride. Let's see how it is balanced. It is balanced only by putting numbers in front. So look at these two numbers. Now, in an attempt to balance chlorine, I'm to put 2 here. So putting 2 here, now chlorine, these 2 affects everything here. So chlorine is now 2, and other side chlorine is also 2. So in terms of chlorine, it's balanced. But in doing so, sodium has become 2. But remember that sodium was 1. So how do I also balance sodium? By putting 2 here. And now if I check, sodium is 2, sodium is 2. Chlorine is 2, chlorine is 2. So this equation is now balanced. You can see that I put numbers only in front. Sometimes you may have to put numbers only in front of 1. Sometimes you may have to put numbers only in front of 2, as I've done here. Let's look at other examples. I have H2O and oxygen, H2 and oxygen to form water. If you look at it, H is 2 on this side, so it's balanced. But in terms of oxygen, oxygen is 2 here, but oxygen is 1. How do I balance oxygen? But I'm allowed to put numbers only in front, so I put 2 in front here. So oxygen is now 2, oxygen is now 2. But in doing so, hydrogen has now become 4. Remember already it was 2. So how do I get the hydrogen balance? I also put 2 here. So now if you check, hydrogen is 4 here, hydrogen is 4 here, oxygen is 2, oxygen is also 2. So now it's balanced. Now you may be asked, if you like, yes, sometimes when you see this, J is for gas, L is for liquid. Aqueous means the solution, the sodium chloride has dissolved in solution, so it is in the solution. So these are what they mean. I'm showing the states in which they are. If you come here, we have aluminum metal reacting with sulfur to give you this. Now, each of them, aluminum is 1, aluminum is 2 here, sulfur is 2 here, sulfur is 3 here. How do I balance? Now, if I put 2 in front here, I've told you that the number in front affects everything. So I have 2 times 3 for sulfur, making 6. How do I make here 6? I also put 3 here. So sulfur is now 6 here. Sulfur is now 6 here. So let's see. By doing so, aluminum is now 4. So aluminum was previously 1. How do I balance aluminum? By putting 4 in front. And now everything is balanced. These are other examples that you can also look at. Here, these are other examples that you can also look at to get the equation balance. So I have that, and then I have this as well, and then I have that. Remember that this one's, some equations like number 5 is already balanced. So you do not have to worry yourself to put numbers in front. Nitrogen is 1, nitrogen is 1. Hydrogen, 3 plus 1, making 4 hydrogens here. Is balanced, 4 on the left hand side, 4 on the right hand side. Chlorine is 1, chlorine is 1. So in some equations, first check. You may not need to put any number in front of anything. It's already balanced if you are lucky. Now, to master and balance chemical equations well, you have to know the reactants, what they are. What they are. If you know what they are, then you can also predict what they are going to form. The first one that I want you to know, I'm going to give you some series of reactions. Make sure you know them. You are able to identify the reactants, that the reactants may be an acid on a metal or so and so. When you know it is an acid on a metal, then you can predict what the products that you are going to form. Because sometimes you may be given an equation and they will ask you to write a product and then balance it as well. So firstly, you must know that when acid and metal react, we get salt and then hydrogen gas is produced. I know you learned this in acid, base, and salt. Another one is that when acid reacts with a base or alkali, know that salt and water is formed. This is the popular neutralization reaction. That's when acid reacts with a base or alkali, we form salt and water. Also remember that when acid reacts with carbonates, we form salt, water, and carbon dioxide. Please, these 3 are the chemical properties of acid. So if you know, you are asked what are the chemical properties of acid, these are the 3. Acid and a metal to give you salt and hydrogen gas, acid in the base or alkali to give you salt and water, acid and a carbonate to give you salt, water, and carbon dioxide. We have other examples of reactions too that I want you to take note of. They are combustion or burning. Whenever we say combustion or burning, it means whatever substance that we are giving you, it is reacting with oxygen in the presence of heat. And always the products are the same. Always the products are water. If it is combustion reaction, the products are always water, carbon dioxide, gas, and then heat, because it is being burnt. So that if I burn glucose and oxygen, I should expect water, carbon dioxide, and heat. And then a reaction between metal and water, also know that to give you alkali metal and hydrogen, alkali solution, and then hydrogen gas. So when you are able to know that this reacting species is a metal, this one is a water, then you should know that you are going to form an alkali solution and then hydrogen gas will be given off. I'll take this into details maybe in my next video. And then the last one is when a non-metal reacts with water, we form acidic oxide. So be mindful of these last two. You can be asked that a metal was put into water and then the solution was tested for either acid or base. Know that it's going to be basic. A non-metal reacts with water and it was tested for acidity or basicity. Remember that I've told you we are going to form an acidic oxide, therefore it will turn blue litmus paper red. Now I'm going to touch on the first three, 1, 2, 3. The remaining, maybe in my next video, I'll present on it. So let's look at the first one. By the way, as a way to help you identify some acids and bases, we have two types of acids. We have the mineral or inorganic acids. Example is the ACl, tetraoxosulfate 6, the triosonitrate 5 acid, and then the what we call carbonic acid, triosocarbonate 4 acid. So these are all acids. You can see that they all start with H. So this is a way, a trick to help you that most mineral acids, they start with H. And then we have the inorganic acid, like ethanoic acid, malic acid that we find in fruits and then in living things. One of them is like this. Then when it comes to bases, bases are hydroxides of metals. So whenever you see any hydroxide, know that it's a base. And also bases are also oxides of metal. So when you see a metal with oxygen like this, calcium oxide, sodium oxide, magnesium oxide, they are also bases. So when we're able to identify that this component is a base, this component is an acid, then you know that when I come here, I have acid and a metal, so I should get salt and water. I have acid and a base, I should get salt and water. So I should get, if acid and a metal, I should get salt and hydrogen gas. Acid and a base, I should get salt and water. Acid and a carbonate, I should get salt, water, and carbon dioxide. So let's go and look at the first one, acid plus a metal. Whenever acid and a metal react, I've told you that we are going to form salt and hydrogen gas. So these are some examples. So I have ACl combining with potassium to form the salt, potassium chloride, and then hydrogen gas will be released. Now, is the equation balanced? Let's check. Hydrogen is 1 here, but over here is 2. So how do I balance it? Let me first put 2 in this hydrogen in front of this hydrogen chloride. So it makes the hydrogen 2, hydrogen also 2. But then in doing so, I have made the chlorine 2. So how do I get the chlorine also to become 2 on this side? So I also put 2 in front of the chlorine on the other side. So hydrogen is balanced, chlorine is also balanced, but then potassium is not balanced because it was 1. So I also put 2 in front as a way of balancing. Now let's look at other examples. Here it is not balanced. If you check, you realize that I only have to put 2 here to get it balanced. Check. Sodium is 1, sodium is 2. So I just have to put 2 here to balance sodium, and everything else is balanced. You can check from the left and right. Then the second one is acid and a base. So the acid and the base, I've told you what are we expecting, salt and water. So I have acid, ACl, base, sodium hydroxide. I'm getting my salt and my water. Luckily for us, every component here is balanced. The same way, acid and a base, I also form that. Luckily for me, everything here is also balanced. Acid and another base, what do I get? Magnesium sulfate. Yes, if I check, this one is not balanced because hydrogen is 2 here, hydrogen is 1. How do I balance it? By putting 2 in front of this. By putting 2 in front of that, I get everything to be hot. Balanced. Let's check. So this and that, what do I get? I get this. I think there's a mistake on the last one. So I should have formed chlorine. Check it well. There's a mistake on the last one. And then I don't see chlorine here. So correct this number 3. All right. So acid and a carbonate give us salt and water. Salt, water, and carbon dioxide. So let's look at some carbonates. So these are what I mean by carbonates plus acid. I get salt, water, and carbon dioxide. Another example, if I'm to balance it, I just put 2 here. Then let's look at another one, carbonate again, acid. I get salt, water, and carbon dioxide. All right, it's good coming your way. Please expect me in my next presentation.